Alright, welcome back. In the last video we actually figured out what our reactions were, our total shears and our reactions were for this structure using the moment distribution method. Here I just redrew the beam with the 40 and the 2 kip per foot and the 60 were given, and we figured out what the reaction at A, B, C, and D were. So we're going to draw the shear moment diagram for this this structure. So for the shear diagram, this is the shear. Oh, that should be for the shear. All units are in kips. Here we have a shear that's 32.756, so it's going to start up here. This is your 32.756. It's going to go a distance of 10 feet. Nothing's going to really happen to it, and then you have 40 going down, so you're going to end up here at negative 7.24, right? And then again, you really don't have anything going on until you get to this B. So B, you have 7.24 down here, and then it goes up a distance of 34.05, which drops you at 26.81. right? And then you have 2 kips per foot going down up to joint C. So 2 kips times, I believe was 30, is 60, so it's 26 minus 60 gives you 33.18, and this is a straight line. Oh, that should be let me actually just draw the straight line. Straight line here, right? And then you have the 61.75 going up, so this is negative. You go up to 28.57. Again, nothing happens until you get to the 60 over here. 60 brings you down to negative 31.43, right? So minus 60. Then again, you keep going, and then you have this 31.43 pushing you back up to 0. Okay? So that's the shear diagram. Let's draw our moment diagram. I'll keep that in the picture. The moment diagram, I'll draw it in. Let's do red line. Okay, and then let's see. It's a good color. Let's do blue. So this is the moment diagram. All units are in kip foot. Now, for our moment diagram, it doesn't start at 0, because if we look at our sum of moments, it actually starts at negative 211, right? So it's negative 211. You start at negative 211 here. 0.8. Okay, so it starts here. And our shear diagram tells us it goes up from this distance to this distance, 32.756. So this area would be how much it goes up, right? So this is 10 times 32.756. You add that to your 211.8. You should be at 115.8, and then again it goes down to I think 101 somewhere. Remember, it should match this. So this is negative 101.4. Okay, and then here you have a zero shear here, so that means the moment diagram is gonna change shape there. This is triangular, so this is gonna be a second degree or a parabolic curve. It goes up here. It's gonna go down here. Okay, so this is gonna look something like this with our moment here. Our moment here should be 78.2. Okay, if you do the math. Down here it's going to be negative 197.25, and then it's going to go up here to, let's see, I believe 231.3. 231.3. It's going to go back down negative 240. Actually, that's bad. The scale is kind of off. So it's going to come down here to negative 240.1. And then if you look back at the diagram, if you look back at the moment distribution, oops, you had a negative moment, but here you have a positive, so it's going to push it back up to 239. It should give you something close to 0. So that's the moment diagram. So this is how you use the moment distribution method to figure out your reactions, and then eventually draw your shear moment diagram. Alright, hopefully that helped some.